Alright, so now finding areas that are enclosed by, which is just very similar to area between two curves. There's one additional step here. So areas enclosed by means they're completely surrounded by two functions. And we're only going to look at the case where my two functions intersect twice. Alright? Twice. Otherwise it gets a little more complicated. So we're going to only look at the case where they intersect twice. Alright, so find the area between. So the additional step to what we did before is these functions do intersect. They intersect twice. Those places where they intersect are the endpoints of my function. Alright, so I'm going to walk through an example of this. So the first step, so this would be the additional step, is we find out where they intersect, the two places where they intersect. So you do that by taking my function f of x, setting it equal to my function g of x, and solving. Alright, so in a simple example are two quadratics. So I've got my first quadratic, which is f of x, which is 2x minus x squared. My second quadratic, which is just simply the x squared. Take my f of x, set it equal to g of x, and solve. Alright, so I'm going to solve it by hand, and you can also solve this on the calculator, which I'll pop up a picture here in a little bit. Alright, so 2x minus x squared equals x squared. So I'm going to move x squared to the other side. And so when I do that, I get 0. So 2x minus 2x squared. And then I'm going to solve it by factoring. I can factor out a 2x, which leaves me with a 1 minus x, right? So when I factor out the whole thing, I still have a 1. Don't forget that. And then a 2 comes out, and I still have 1x left over. Alright, so it means x equals 0 and x equals 1 are my a and my b, right? And so they intersect at 0 and 1. And what that translates to, if I go and graph these functions, so I go in here, clear out what I have, and so x squared is one function, 2x minus x squared is my second function. Graph. Alright, so there's my x squared. There's my, so if you look there, they intersect here at 0 and 1. You'll see that on my graph. And so the area I want is that little bitty area. So I know it's going to become a small number, that little area between. And so if I go and put this in my notes, and so, again, my graph, this would be my x squared function, which was g of x. And then in red, I'm going to do my f of x. And so they intersect here at 0 and 1, right? This function comes up and intersects there at 0 and 1. There's my f of x function, which is the 2x minus x squared. And so this is the little bit of area I want to find, right? I want to find this area. And see, it's completely enclosed by, right? It's enclosed by both functions, completely surrounded by both functions. The area starts at 0 and stops at 1, where they're equal, right? My area between the two curves that I'm interested in, this little bitty area here, is between 0 and 1. All right, now based on the picture, I can actually answer the next question, but I'm going to do it both by hand, and then we'll look at the graph of it. All right, so I know the area between or enclosed by f of x and g of x is over the interval 0 to 1. Starts at 0, stops at 1, right? That's where it's enclosed by. And so the second thing is, well, when I want to set up my integration, I have to take my bigger function minus my smaller function. So that's the second thing I have to figure out, well, which function's bigger or small? And you can do this either graphically or by hand. I already have the picture up here, and so I'm going to show you the graphically first. So if I look at my function here, it's a little messy here. Remember, the red part was my f of x, the blue part was my g of x. So if I kind of zoom in on that, so if I kind of zoom in, all right, my red function was f of x, my blue function was g of x. And again, I kind of elongated here. But if I look here, meaning, right, this is going off to infinity, this is the function above. So between 0 and 1, and actually only between 0 and 1, everywhere else it's not true, between 0 and 1, f of x is the bigger function. The red is above the blue between my interval 0 to 1. Alright, and so I know that f of x is greater than g of x based on the graph. But there is a way to do this without the graph, if you were solving this without having the graph. What you do is, well, you pick a number in the interval a to b. So in this case, between 0 and 1. So I'd pick maybe 1/2, right? Or 0.5 is easier to use in the calculator. And then what you do is, well, you find g of 1/2 and f of 1/2, which, since they intersect at 0 and 1, that's where they cross, between 0 and 1 of them has to be bigger than the other, right? And so I just have to figure out, well, which one's bigger? We'll pick a test point and figure out which bigger. And so when I plug 1/2 into g, it comes out 0.25. When I plug 1/2 into f, it comes out 0.75. And so f is the bigger function, right? F is bigger than g, right? 75 cents is bigger than 25 cents. And so I've checked it. So there's two ways to do it. You can either graph it and visually see which is bigger, or you can pick a test point, right? Again, I don't care which way you do it. If you solve it graphically, just show me the picture. If you solve it by testing points, well, make sure you show me the points that you tested so I know how you got the answer you got. I know f of x is greater than g of x. Which means when I set it up, there's two ways to go, right? You either pick f first or g first. And again, it's based on which is bigger. And so in our example, we do the first case, right? Because f of x was bigger than g of x. But if it was the other way around, we pick the second example. So again, in our example, f of x was greater than g of x. So we picked integrated from a to b, f of x minus g of x. So we go 0 to 1, right, because that's my a and my b. F of x, which was 2x minus x squared, subtract away g of x, which was x squared with respect to x. So when we integrate 0 to 1, if we simplify that, we get 2x minus 2x squared dx. And so this is what we're going to go and regraph. It'll find me a new area. So if I go to my graphing calculator, I'm going to clear that out. And I'm going to use this. So 2x squared. Try to get it set there right. Oops. All right, maybe I should rewrite it. 2x minus 2x squared. Graph. And so I've got my new function. And so again, the area I'm going to find is little bitty area between 0 and 1. So second, trace, 7, 0, 1. And it'll find that little bitty area, which is 1/3. 0.333 repeating, which is 1/3. And so again, it regraphs it, finds that new area, just like it did in the previous cases. And it comes out the area between my curves, right? The area under that curve between 0 and 1 was 1/3. That same area is equal to this area here, right? The area between the two functions. That area there is 1/3. Right? I had to regraph it to use my fundamental theorem of calculus, but it's the same area between the curves. As long as I take the bigger function minus the little function. That's the biggest thing, is you always have to take the bigger function minus the littler function. All right, solve the definite integral, which I've done above. Remember, area should always come out positive, never negative. If your area comes out negative, it means you subtracted incorrectly, all right, which usually just means flip it around, all right? So keep that in mind. All right, so we'll do the next example in the next video.